Okay, in this tutorial we're going to talk about 2020 paper 2 question 2, and the topic we're looking at is the circle. Now in this question you're given a circle with a tangent, and we know that a point on the tangent is the point B. A is the centre of the circle and T is the point where the tangent and the circle touch. We've been asked to find the distance BT. Before we even worry about the diagram at all, the first thing you should do is take the equation of your circle, find the centre and find the radius. So that's exactly what I did. The coefficient of x in the equation of the circle is 2g, so you divide by 2 and change the sign, and you work out that the x value of the centre is 2. The coefficient of y in the equation is 2f, divide by 2 and change the signs and you get minus 1. So the centre of the circle, the point that is labelled as A on the diagram, is 2 minus 1. Then it's easy enough to get the radius. If I go to my maths tables, it tells me the radius of a circle is the square root of g squared plus f squared minus c, where I've worked out g is minus 2, f is 1, and c is at the end of the equation. When I sub it all in, I end up with the radius equals 3. I'm going to just put this on the diagram now, and we're going to talk about how we can find the distance bt. Okay, so the diagram we're given looks something like this. I've deduced now that the point A, the centre of the circle, is 2 minus 1. And I've worked out that the radius of the circle is 3. So I know the distance from A to T is 3. What we need to do is join up A and B here to form a right angle triangle. If I use my ruler and draw a straight line from B to the centre of the circle, I have a right angle triangle. Because at the point of contact, the tangent and the radius are perpendicular to each other. So you should recognise here how we're going to find the distance BT. We're going to use Pythagoras Theorem. If you know the length of two sides in a right angle triangle, you just use Pythagoras to find the third side. So this question is easy enough from here. What I'm going to do is use the distance formula from my maths tables to get the distance from the point 5,8 to the point 2 minus 1. And then once I have that distance, I'll have two sides in the right angle triangle. I'll use Pythagoras and I'll find the distance from B to T. So I went to my maths tables and I took down the distance formula that allows me to get the distance from two different points. I labelled A and B as x1, y1 and x2, y2, and when you sub in, you get the square root of 90. So I've worked out that the distance from A to B is in fact the square root of 90. Now we just simply use Pythagoras Theorem, we'll be able to get the distance BT. So I subbed into Pythagoras Theorem and I said that BT squared plus 3 squared will give me the square root of 90 squared. It's basic enough maths, and when I simplify it down, I end up with the distance BT is equal to 9. And that's my final answer for part A. Okay, in part B, we're asked to find the equation of circles C1 and C2. When we've been given a load of information, 3 pieces of information about each circle. I know the radius of each circle is 5. And the centre of each circle lies on the x-axis. We know from coordinate geometry at junior cert level that if the centre is on the x-axis, that if a point is on the x-axis, then the y value is 0. So I immediately know that the y value of the centre must be 0 if it's on the x-axis. So the centre of the circle is something 0. In this case, I'm calling it h0. The equation of every circle can be written as x minus h squared plus y minus k squared equals r squared. So I'm using these two pieces of information and I'm subbing in. I know that instead of the k, I can put in a 0. Because I know the centre of the circle here, the y value of the centre of the circle is 0. And instead of or, I can sub in 5. So when I simplify that down, the equation of both of these circles is x minus something squared plus y squared equals 25. So based on the fact that the radius is 5 and the centre is on the x-axis, the only thing that I don't know is the h. The only information I need to find is the x value of the centre. And the only other piece of information I was given about these two circles is that the point 1, 4 lies on each of the circles. If the point lies on the circles, that means I can sub in x equals 1 and y equals 4, and it should work out. So what I'm going to do here is I'm going to sub in x equals 1, I'm going to sub in y equals 4, and when I do that, the only thing I won't know is h, and I'm going to get two possible values for h, and then I'll know the centre and the radius, and I'll get the equation of the two circles. So that's exactly what I did. Instead of an x, I subbed in a 1, instead of a y, I subbed in a 4. And when I simplify it down, 1 minus h by 1 minus h, I get 1 minus 2h plus h squared. and 4 by 4 gives me 16. At this stage I have a h squared, a h and a number, so I recognise I had a quadratic equation. I move everything to the left hand side and I get h squared minus 2h minus 8 equals 0. And when I factorise and solve it, my two values for h could be 4 or h could be minus 2. So the centre of the circles is 4, 0 and the other one is minus 2, 0. Now that I know the centre and the radius of the two different circles, I'm going to sub into this and get the equation of the two different circles. Okay, so from there it's fairly straightforward. If you go to page 19 in your maths tables, it tells you the equation of any circle is x minus h squared plus y minus k squared equals r squared. I've worked out that in one scenario, the centre of the circle is 4, 0 and the radius is 5. Where the x value of the centre is h, the y value of the centre is k. You simply sub into your formula and your answer works out as x minus 4 squared plus y squared equals 25. So this is your first answer, the equation of one possible circle. However, it's also possible that the centre could be minus 2, 0 and the radius could be 5. If you sub into the same formula again, your final answer this time works out as x plus 2 squared plus y squared equals 25. So that's your second answer for part B.